ನಮಸ್ಕಾರ ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. I am P.R. Hampioli, Professor, Head of Department of KLS JIT Belagavi. Under the umbrella of e-section of VTU, we are learning Fourier transforms of Engineering Mathematics 3. We have come to the sixth lesson now, sixth lecture, so to say. So I will be taking the help of one previous example for today's first example. Dear students, I think you are ready with pen and your pad, because unless and until you write, you will not be used to the symbols, because the symbols rule mathematics. Mathematics is the language of symbols. So welcome to class number 6, Fourier transforms. So in the today's first example, we are find Fourier sine transform of x by 1 plus x square, or sometimes this may be asked like this: find Fourier sine transform of f of x equal to x by 1 plus x square. Now it is very clear that we'll have to consider the definition of Fourier sine transform. What it says: Fourier sine transform of any function f of x from x domain to s domain, we are transferring it. Some s function we get, but to make it clear, this is known as, this symbol tells that it is sine transform. So what makes it? This transformation is done by multiply the given function to sine function. So forcibly bring s parameter and remove this x by integration process 0 to infinity. I'm repeating that. If you go on multiplying different weight functions, different limits, you go on getting different transformations. You can create your own transformations. If they are useful, it will be in your name. Now simply is, you will have to substitute the value of f of x, here. So shall we do that? This is equal to 0 to infinity x by 1 plus x square sine of sx dx. So now to find this, I'll take the help of the previous example. Exactly this part was very much present while we found Fourier cosine transform of 1 by 1 plus x square. So what you have to do is, you should consider I equal to Fourier cosine transform of 1 by 1 plus x square, which is nothing but 0 to infinity 1 by 1 plus x square cos function sx dx. Then go to the, I'll just show, you have to go on writing exactly what previous example is there. Same thing, very much same. Find the Fourier cosine transform of 1 by 1 plus x square. Go on writing same thing till the end, I equal to this, and till still you cannot find, as you cannot find directly, you differentiated with respect to s, started creating differential equations. You got di by ds, you got d square I by ds square. In the previous example, you solved this using your complementary function part, and hence in the previous example, if you note this part and exactly this part. So I am coming to that part now, exactly this part. When you consider this part, if you can observe that di by ds, I am requesting you to read that this di by ds if you transfer minus sign, if you transfer minus sign this side, if you transfer minus sign this side, it looks like this: minus di by ds is equal to 0 to infinity x by 1 plus x square sine of sx dx. Now exactly this part is nothing but, this part is nothing but Fourier sine transform of x by 1 plus x square, what we wanted. So what you should find is minus di by ds in this same example. I am repeating, do the same example till the end. Instead of writing the value as I, you find the value as minus di by ds. So if you go on finding the value of minus di by ds, you will get as it is. The answer is this value. Instead of putting the values in I, you put the values in di by ds. So you are going to get a very similar minus di by ds answer. So this I am taking minus di by ds from 5. If you do that, you are going to get minus di by ds. Perform all the previous example here. Minus di by ds equal to exactly pi by 2 e raised to minus x. The answer of this is exactly pi by 2 e raised to minus x. Try to do that. See, always you can mail me prhampiholi@git.edu, or feel free to contact me. The first introduction lecture also it is there. So allow me to go for the next. Allow me to go for the next example. The next example, again little bit different it is. The next example, but before the next example, whatever we did for x by 1 plus x square, 1 by 1 plus x square examples, suppose this example is, if Fourier cosine transform of a function, Fourier cosine transform of a function is 1 by 1 plus s square, 1 by 1 plus s square, show that Fourier cosine inverse of 1 by 1 plus s square, that is equal to some x function, is exactly e raised to minus x. So hint I am giving you, hint, this is same thing as Fourier transform of, very similar to Fourier cosine transform of 1 by 1 plus x square example. Very similar. Very similar. So what you have to do is, in a similar way, consider inverse Fourier cosine transform, which is Fourier cosine inverse of any function of s is 2 by pi 0 to infinity. Whatever the function is there, to that you have to multiply by cos sx ds. You write this as I and generate, hint is again, generate di by ds, d square I by ds square. Instead of di by ds, you will get d square I by di by dx, d square I by dx square. So in this example, whatever is there, you have to interchange, almost 99% interchange the role of x and s. So you are going to get a differential equation of the type d square I by dx square minus I equal to 0, very similarly. And if you go on proceeding, you are going to get finally the value of I equal to f of x equal to simply e raised to minus x. The next example also very similar. Find the Fourier sine inverse of s by 1 plus s square, or show that Fourier Sine inverse of s by 1 plus s square is also my e raised to minus x. The hint is very similar to the similar example. So now try this. Otherwise, feel free to tell me. I'll take one more class for that if at all you want. But I think you can try that and you will get it. Because they are similar, I'll go to the which is not similar example. Now this is one of the examples which is usually a little different. This example you need to concentrate because instead of usual x and s, little bit of symbols also I am changing. Please take very carefully. This will solve completely. Solve. First I am using this word. Solve the integral equation. Solve the integral equation 0 to infinity f of theta cos of alpha theta d theta equal to, the output will be theta will go, alpha will come. Output is either 1 minus alpha or 0. 1 minus alpha in the range of 0 to 1, and outside this range it is. So here instead of f of x, let me complete this and hence show that 0 to infinity, you have seen that sin t by t is pi by 2. But in this case we have to show that sin square t by t square, that is also pi by 2 amazingly. But here instead of asking find the inverse Fourier cosine transform, we are asked to find f of theta. Solve this, we have to find what is f of theta. So if you are asked to find differential equation dy by dx minus y equal to 0, what do you do it? You find the value of y. Solve means you find the value of y. If the equation contains derivatives, it is a differential equation. If the equation contains integration, it is integral equation. Actually both are one and the same in different forms. So to find f of theta, you have to find inverse Fourier transform. So it is as if given like this: f of x cos of sx dx equal to 1 minus s or 0. So given the s function, you have to find f of x function. Given the s function, you have to find x function, means you have to go reverse. Since here cos is there, you have to find, consider inverse Fourier cosine transform. But in terms of alpha theta, slowly we will talk because we are used to s and x language. So in any language we should be able to write. Structure should remain in our mind. Structures of definitions. Inverse Fourier cosine transform. So what happens? We get f of theta back equal to f of theta equal to 2 by pi, okay, some f of alpha. What is f bar alpha? I'll tell you. F bar of alpha of cosine transform into cos of alpha theta d theta, where this part we consider it as fc bar of alpha. So that I'll write here. First step I can write here only. Let you can write first step as this, given that you are given a integral equation which is 0 to infinity f of theta cos of alpha theta d theta is some function of alpha which is 0 to 1 and alpha greater than 1. Let us consider this alpha part as function of alpha. Since it is because of cos it has come, cosine transform fc bar of alpha. Now this part will have to substitute here. So the whole 0 to infinity range, we'll have to break into two parts, 0 to 1 and 1 to infinity, 1 to infinity 0. Here 1 to infinity, this becomes 0, 1 to infinity, this becomes 0, and the remaining part is 1 minus alpha. So what we are trying to do is we are trying to extract f of theta by inverse Fourier cosine transformation by substituting the value of this as 1 minus alpha in the range 0 to 1. So now f of theta takes the form 2 by pi 0 to 1 plus 1 to infinity. In 0 to 1 range, the value is 1 minus alpha, cosine function as it is, and so instead of d theta, we'll have to consider this part as, yeah, I heard it, somebody telling me d alpha. This is d alpha. This part becomes 0. So proceeding, so that integration, now we are coming to the integration part. What is the integration? F of theta equal to 2 by pi integration with respect to alpha, 1 minus alpha as it is, again plus minus alternative, flower bracket integration term, differentiation of 1 minus x is minus 1. Similarly, 1 minus alpha differentiation is minus 1. Once again, differentiation of 1 minus x is minus 1 with respect to x, and differentiation of 1 minus alpha with respect to alpha is minus 1. Instead of talking in terms of x language, we are talking in terms of alpha language. Now, this here directly integration, cos integration, sine. With respect to alpha we are integrating, means theta will come down. Again, sine integration, minus cos of alpha theta divided by theta square. One more theta will come. Integration is over. We have integrated with respect to alpha. Alpha equal to 0 to 1. So now let me take the little bit liberty, which is, if you substitute the limits and find the answer, upper limit 1, if you substitute here 1 minus 1, it becomes 0. Lower limit 0, here I am substituting upper limit minus lower limit, suppose. Okay, upper limit 1 minus 1, 0, lower limit alpha equal to 0, sine 0, 0. So first term it is 0 minus 0. I am coming to the second term, which is 2 by pi minus minus minus, 3 minus signs make it minus 2 by pi, upper limit 1, wherever alpha is there you put 1, which is alpha equal to 1 means it is cos of theta, minus alpha equal to 0 means cos 0 is 1, theta square as it is. So it is 1 minus cos theta divided by, so what we are asked to find is f of theta only. So here is the answer, 2 into 2, 4 by pi square. Okay, 4 by pi square, 1 minus cos theta divided by theta square is one answer. But 1 minus cos theta, how we can write? F of theta equal to 4 by pi square. 1 minus cos theta you write 2 times sine square theta by 2. Sorry, this is 2 by pi square because of only 1 2. 2 times sine square theta by 2. Okay, so I wrote only numerator different, divided by theta square. So f of theta can be finally written as 4 times sine square theta by 2 divided by theta square as the answer to this question. So this we need to see once again, because it is solve the integral equation. Carefully you see, it is nothing but Fourier inverse only. Solve the integral equation. Okay, so what you do is, You write wherever theta is there, you write x, and wherever alpha is there, you write s, and redo it. Okay, redo it in terms of one more symbol. Redo it, please. So now, as a homework, you do this. Just replace theta equal to x and alpha equal to s. Solve the integral equation means you have to extract f of theta outside. Since cos alpha is there, it tells that you apply inverse Fourier sine cosine transform. But the right hand side part, in terms of alpha, some alpha term we take, but judiciously we take the value of this as 1 minus alpha as fc bar of alpha. Now, if I apply the inverse Fourier cosine transform definition, 2 by pi to this alpha function, you have to multiply by cos alpha theta and d alpha, carefully, d alpha. So now this part, therefore, from here to here, if you see, this integration has to be broken into two parts, because f3 bar of alpha has got two ranges, 0 to 1 and 1 to infinity. 0 to 1, it is 1 minus alpha. 0 to 1, it is 1 minus alpha. And after 1, it is 0. So 0 to 1, 1 to infinity. 1 to infinity is 0. 0 to 1, instead of fc bar of alpha, it has come as 1 minus alpha. So it reduces to the question of integration by parts. Applying general rule of integration by parts, we get this. Applying upper limit minus lower limit, first term is becoming 0. So second term is becoming in terms of theta. After integrating, alpha should not remain. That many times I am telling you. So that f of theta in its different forms, 4 by pi square sin square theta by theta square. Now, to find the evaluation part, let us see what we consider. Show that this part is there. To find the evaluation part, I'll consider the same thing. See carefully. To find the evaluation part, so small, even this is simply 2 by. To find the evaluation part, this 2 by pi and 4 by pi, please, simply 4 by pi. For evaluation part, consider 0 to infinity, whatever was given. Okay, f of theta cos of alpha theta, f of theta cos of alpha theta d theta equal to that function of f of alpha. Now what is f of theta we found? Just now we found f of theta value, which is 0 to infinity. I substitute here 4 by pi sin square theta by 2 divided by theta square. What I did, I am substituting this as it is for f of theta. I am substituting this f of theta here. So remaining cos of alpha theta as it is. Wherever there is a reduction part, you will have to select this part alpha. Alpha part has got two values, 1 minus alpha or 0. This is in the range 0 to 1. This is alpha greater than 1. Now if you see, what you want to reduce is, you don't want this part. Means this part you want 1. For what value of this it becomes 1? For alpha equal to 0. For alpha equal to 0, fc bar of alpha is 1. So that I am going to get here also 1. So I am putting the value of alpha 0. Select or choose judiciously alpha equal to 0. You cannot select theta because right hand side there is no theta logically. So alpha equal to 0, 4 by pi sin square theta by 2. I'll take a small liberty here. This 4 also I can transfer afterwards this side. At present theta square, alpha equal to 0, it becomes 1, and d theta as it is and fc bar of 0, fc bar of 0, 0 is here, alpha equal to 0, 1 minus 0 is 1. Now accept this part, sin square theta by 2, 0 to infinity, sin square theta by 2 whole divided by theta by 2 whole square. That means this 4 comes here, got adjusted. Pi you transfer this side, equal to pi into 1. Now remains is this theta by 2, you put it as some t or some x. So here t I'll take. This implies that d theta, this d theta value is 2 times dt, and there is no difference in the theta and t. Theta equal to, I mean t equal to theta by 2, theta equal to 0, t equal to 0, theta equal to infinity, t equal to infinity. There is no problem of limits remain the same. Therefore, in terms of t language, after transforming, theta should not remain basic. T should appear, theta by 2. Here, wherever theta is there, theta by 2 t, theta by 2, this theta by 2, theta by 2, theta by 2 t. If I substitute, and this d theta becomes 2 dt, can you see this? What we are going to get? 0 to infinity sin square t by t square. Wherever theta by 2 is there, I have substituted 2 d theta, 2 dt, okay, 2 dt equal to pi, t 2 dt pi as it is. So here we are having final answer. Therefore, final answer, we are asked to find the value of sin square t by t square dt, which is nothing but pi transfer that side. Amazingly, this also remains pi by 2. Amazingly, this also remains as pi by 2. Once again, why not once again? So solve the integral equation. To find f of theta is our aim. To find f of theta, you have to invert completely. Invert means inverse Fourier cosine transform. So I considered this is some function of alpha, Fourier fc bar of alpha. I took this. So that given function we wrote, and 1 minus alpha, this part is fc bar of alpha. So considering inverse Fourier transform, f of theta is 2 by pi 0 to infinity. In terms of d alpha, I have to integrate to whatever alpha function is there, to that cos of alpha theta. Then 0 to 1, 1 to infinity broken, this part 0. Here upper limit minus lower limit 0 part. Here only theta part remains like this, 1 minus cos theta by theta square. 1 minus cos theta by theta square. Hope this should not trouble you. I'll rub this part. Wait. Okay, this part is simply theta part. Now, after finding this part, we are finding the evaluation part. For evaluation part, in this 0 to infinity f of theta cos alpha theta d theta, put the value of the latest 4 by pi sin square theta by 2 by theta square. So then you choose judiciously alpha equal to 0. This is also becoming 1 because of the definition. Alpha equal to 0, this becomes 1, and cos 0 is 1. So this part remains. Again, carefully, this you want t, so put theta by equal to t, because in the main question only this you want t. So if you put that in terms of t language, if you transfer it, you are going to get this answer. Once simply transfer t this side, I mean to this side, you get pi by 2. So let us go for the next type of examples, which is sometimes we are asked some more easy examples. Example, Find the Fourier sine and cosine transform of find just wait. So we are trying to learn these all by online. We are in the new mode of online classes. So nice it is. So we proved all these remaining parts. So nice. We always get used to the new things. That is so nice always. Find Fourier. This example is simple but many times asked. Fourier sine and Fourier cosine transforms of fx equal to 2 times e raised to minus 5x plus 5 times e raised to minus 2x. So let us find first Fourier sine transform by the definition of by the definition of Fourier sine transform by the definition of Fourier sine transform. Fourier sine transform of any function f of x is equal to 0 to infinity f of x into sine of sx dx. Now fx is given like this. Let us write that also. We are given fx equal to 2 times e raised to minus 5x plus 5 times e raised to minus 2x. Why not substitute here the value of f of x, value of f of x as value of f of x here. Let us do that. We are going to get Fourier sine transform of given function as f of x is 2 times e raised to minus 5x plus 5 times e raised to minus 2x. In the remaining part are same. Remaining part 0 to infinity as it is. So f of x is over sine of sx dx. This is equal to, there are two terms here. This is known as linearity property of sine functions, which is there for Fourier transform also. So first multiply these two separately. That is, by linearity property, 2 times 0 to infinity e raised to minus 5x. If it is not negative sign, we are not going to end with Fourier transform, because Fourier sine transform, cosine transform or Fourier transform should not end in infinity. You should end in some function. So minus is necessary. Sine of sx, first two sine is over, plus second two sine e raised to minus 2x sine of sx dx. So now you might have noticed that only this part 5 and 2 are different. So that part we shall make use of. Fourier sine function, sine transform now looks like this. Fourier sine transform now looks like this. 2 times as it is. Integration of this using the again e raised to alpha x sine of beta x formula, what we are going to end up with is e raised to alpha x by alpha square plus beta square alpha sine minus beta cos. So in this case alpha is -2, beta is s. Put alpha equal to -2, beta equal to s. So we are going to get e raised to -2x upon -2 square is 4 plus s square into bracket -2 sine minus of s cos. This whole thing between x equal to 0 to infinity. As usual, e raised to minus infinity is tending to 0. Upper limit is 0, which is plus this term we forgot, plus 5 times, very similar, 5 times e raised to, so first I wrote this term, so I'll write 5 times here. First I wrote this term 5 times. Second I am writing this term 2 times e raised to minus 5x divided by 25 plus s square. First I have written this term 5 times, apply the formula. Now I am writing this term. First term is written here. Second term is written here now, which is into bracket -5 sine minus s cos x equal to 0 to infinity. Now there are two terms. So let us see how we evaluate these two terms. F's Fourier sine transform is therefore equal to 5 times as it is, upper limit because of e raised to minus infinity 0 minus the lower limit. So this s has no work with limits, 4 plus s square as it is. Lower limit x equal to 0, 1 into flower bracket x equal to 0, this part is 0 minus this minus I am telling minus x equal to 0 cos 0 1, so minus of this minus s. Very similar term will get here for 2 times also, plus 2 times without much delay, upper limit e raised to minus infinity 0 minus lower limit 25 plus s square as it is. So you are going to get 1 e raised to 0 1, this part becomes 0 sine 0 minus of this part becomes cos 0 1 minus of minus s. So now we have to simplify. After putting limits, there is no x here, no x, so that whatever the function of s we get is known as Fourier sine transform we got, which is equal to 5 times s upon s square plus 4 because it is positive. Similarly 2 times s upon s square plus 25. Very similarly we can do for cosine transform. Why not we should do now? Instead of sine, you put cosine here, you put cosine, you put cosine. Let us consider very similarly because we are asked both sine and cosine transform. So now if I write again considering Fourier cosine transform, Fourier cosine transform of the given function, definition tells that this is nothing but 0 to infinity to the given function you multiply by cos function and integrate. So given function is nothing but 0 to infinity 2 times e raised to minus 5x plus 5 times e raised to minus 2x. To this you multiply cosine function and integrate. So again, separate by linearity property, Fourier cosine function, some function of s we get 2 times outside 0 to infinity e raised to minus 5x cos function, cos sx dx plus 5 times 0 to infinity e raised to minus 2x, again cos function sx dx. So that whatever the first integration is there, very similarly 2 and 5 roles interchange. Now 2 times applying integration rule, e raised to minus 5x upon 25 plus s square minus 5 cos, if cos is there, cos comes first, minus s sine, integration of first term is over, very similarly plus 5 times, so this plus this plus 5 times this 5 I wrote 0 to infinity, I have to integrate e raised to minus 2x upon 4 plus s square lower bracket minus 2 cos, very similar to the previous one, minus s sine, so this also 0 to infinity, this also 0 to infinity, so wherever x is there, x equal to e raised to minus infinity, so function first I'll put here 2 times upper limit 0 e raised to minus infinity, lower limit minus of 25 plus s square e raised to 0 1 into flower bracket minus 5 remains, minus 5 into 1 remains, and this becomes sine 0. Very similarly the next one 5 times upper limit e raised to minus infinity, upper limit e raised to minus infinity 0 minus lower limit e raised to 0 is 1 divided by 4 plus s square as it is, lower bracket, when I substitute x equal to 0 here, this becomes minus 2 remains, cos 0 1 minus of 0, so that you can observe that what remains is, so nice answer remains 2 into 5 is 10, 5 into 2 is 10, minus of minus plus, minus of minus plus, so both the terms contain 10 upon plus 10 upon. Practice these examples. Now let me go to the next example. If at all we are asked Fourier sine transform of a particular function, suppose Fourier sine transform, find Fourier sine transform of f of x equal to has got two parts, either sin x or 0. Sin x is between 0 to a and x is between greater than a. So now Fourier sine transform of any function is 0 to infinity. Fourier sine transform of any function is 0 to infinity f of x into sine of sx dx. But you have to break this whole part into 0 to a to infinity. 0 to a it is sin x and a to infinity it is 0. So 0 to a plus a to infinity, 0 to a it is sin x sine sx dx, and this part it is 0. If I consider this as sine c minus sine d formula, then I am going to end up with this half of 0 to a. This is cos of c minus d, I can write, which is sx minus sx minus sx minus x. If I take s common, s minus 1 into x minus of sx plus x c plus d, which is cos of s plus 1. So I applied sin c sin d formula, and now integration becomes so simple, which is, dear friends, given function is this 0 to a only remains. So to this I have to write sin x, sin c sin d formula, cos of c minus d, cos of c plus d. C minus d means sx minus x, c plus d means sx plus x. Now it is straightforward integration, which is equal to half of cos becomes sine of s minus 1 x upon s minus 1 minus, as it is, sine of s plus 1 upon s plus 1, x equal to 0 to a. So wherever x is there, you have to substitute. Wherever x is there, we'll have to substitute. Here also x is there. Once a and 1 0. So 0, when you substitute, lower limit is 0. So wherever x is there, it comes a, and that becomes the final answer. So that Fourier sine transform of a given function, Fourier sine transform of a given function, therefore looks like this: half of upper limit a and a. If you substitute, our answer is over s minus 1 into a upon s minus 1 minus of sine of s plus 1 into a upon s plus 1 minus 0. I am neglecting this part, is the answer to the whatever we are finding. So that, dear friends, remain one or two questions which I may do for some more time. So one more example I would like to do with your patience. Last example, today's last example, which is many times asked in examination. That's why I would like to do this last example. Find the Fourier sine transform of, or even you can find Fourier cosine transform of. Find the Fourier cosine transform of certain function is there, which is the break function, which is breaking into three parts: x, or 2 minus x, or 0. This has got certain ranges: 0 to 1, 0 to 1, 1 to 2, and more than 2. Now when you know the definition of Fourier cosine transform, it is not difficult to find the solution of this. Fourier cosine transform definition: 0 to infinity to the given function you are multiplying by cos function, which is again broken into three parts: 0 to 1 here, 1 to 2 here, and 2 to infinity. 0 to 1 it is x, 1 to 2 it is 2 minus x, here it is 0. This picture, if at all you have got, always you can proceed ahead. 0 to 1, 1 to 2, 2 to infinity. Corresponding values, if you go on substituting, first here it is x, here it is 2 minus x, here it is 0, and you have to add all these. So cos sx dx, as it is when I substitute, it is cos sx dx plus cos sx dx. Integrating by parts, first one, it looks like this: 0 to 1 is there, x into sine function divided by s minus x becomes 1. Sine becomes minus cos sx divided by s square. This part is over, and plus second one, instead of x it is 2 minus x. Integration part remains same. Can you observe that? So if you write one below the another in such break functions, integration parts remain the same. Minus of, since differentiation of this is minus 1, I'll write minus 1 here, and minus cos sx by s square. What we did, if you have not forgotten, how to do the general rule of integration by parts? Polynomial first you write, go on differentiating, x becomes 1. This integration you have to go on doing, cos becomes sine sx by this constant s comes down every time. Again, if you integrate, one more s comes. Similarly here, the only thing is whatever the s function comes, that becomes the answer. So now take some time, 1 minute for this, and see what is the answer you can find for this. What do you have to find? Wherever x is there, you put 1. Shall we start? So upper limit minus lower limit. 1 ones, 0 ones. So 1 sine of s by s minus lower limit 0. First term is over. First term over. So minus of minus plus. Minus of minus plus. Second term. Upper limit 1. So divide by s square, I'll write first. Upper limit 1 cos of s minus lower limit cos 0, it is 1. So that this term, this entire term, upper limit minus lower limit, is over. Now again a big plus, again we are coming to this plus. When you substitute again upper limit here, 2 minus 2, it is 0. Come to lower limit 1, 2 minus 1. Okay, minus of the lower limit, 2 minus 1 is 1, x equal to 1 sine s by s. Okay, then come to the last term, upper limit minus lower limit, minus minus minus, totally 3 minus signs make it a minus term. Upper limit minus lower limit, upper limit is x equal to 2 cos of 2s minus lower limit is x equal to 1 by s square. So that, can you do this? So if you simplify fc bar of s, what you are going to end up with. Once again, let us see what you did. Given function x 2 minus x, in the respective ranges you divided. So when you substituted cosine function for this, so this you are going to get x sine sx by s minus of 1, sine becomes minus cos sx by s square. Hence second term similarly 2 minus x. So here sine sx by x, and this remain the same. Upper limit minus lower limit, term by term we are substituting. For your sake I am telling once again. See, upper limit x equal to 1, x equal to 1 sine s by s minus lower limit 0. Here also minus of minus plus, upper limit is cos s minus cos minus 1 by s square. So where you are going to get cos s minus 1 by s square. Similarly here upper limit is 0, 2 minus 2 minus the lower limit x equal to 1. So these are 3 minus signs. Upper limit x equal to 2 minus 1 lower limit. So shall we end up with the simplification? You can very easily see that sine s by s minus sine by s, they are getting cancelled. Okay, these two are getting cancelled. So remains are cos s, cos 2s terms. Here minus 1, here plus 1 also getting cancelled. So we are going to get cos s minus cos 2s divided by s square. So cos s remains here. cos s minus cos 2s divided by s square. So can you find instead of sine cosine sine function of this? So that becomes for today's lecture coming to an end. Dear students, we have come to the end of all the Fourier transform examples. To end up with, what all we had is six definitions of Fourier transforms, inverse Fourier transforms, corresponding Fourier sine transform, inverse Fourier sine transform, corresponding Fourier cosine transform, inverse Fourier cosine transform. So you need basically some minimum type of integrations. You need basically minimum types of integration uh, properties. So if you practice, this is also a better chapter. If at all you don't have any problem, otherwise you can definitely contact us. In the next class, we'll be starting with Z transform. Till that, bye, please practice, take care, be safe, and wish you all the best always. Thank you so much. Bye.